In this video, we are going to study sketching of functional curves. For a curve y equals fx, a general method of drawing a rough sketch of the curve represented by a given functional relationship is to pick some convenient values of independent variables x1, x2, x3, x4, x5, etc. and from given functional relationship calculate the corresponding values of y1, y2, y3, y4, y5, etc. and get coordinates of points x1 y1, x2 y2, x3 y3, x4 y4, x5 y5, etc. and plot them on xy plane and draw a smooth curve, say like this, passing through them. This rough sketch helps us to find length, area, volume, etc. of various shapes formed by combination of various curves. Therefore, it becomes important to learn how to draw rough sketches of various functions. We are going to study this and more techniques in this video. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. First, we will see how to sketch some standard curves. Straight lines. General equation of a straight line is y equals mx plus c, where m is slope of the line dy by dx, or also known as gradient, and c is y-intercept made on the y-axis. We will sketch straight line y equals 5 minus 2x. Here, when y is 0, x is 5 upon 2, and when x is 0, y is 5. By plotting these 2 points on xy plane, we can sketch this straight line as. Next, we will sketch straight line y equals 2x plus 1. When y is 0, x is minus half, and when x is 0, y is 1. So by plotting these 2 points on xy plane, we can sketch this line y equals 2x plus 1. A quadratic function y equals ax square plus bx plus c represents a parabola, and simplest parabola y equals x square is shown here. Equation of a standard circle is x square plus y square equals r square, where r is radius of this circle. Moreover, the center of this circle is at the origin. Obviously, its rough sketch will be of this type: a circle with center at the origin and radius equals r. A general circle whose center is at point hk is given as x minus h whole square plus y minus k whole square equals r square, where r is radius of this circle. To draw a rough sketch of such a circle, all we have to do is to specify the center of the circle h, k and draw a circle with radius r. Now we will see how to draw sketches of trigonometric functions. The first among them is y equals sine theta. Sine 0 is 0, therefore this curve emerges from the origin. Sine pi by 2 is 1, sine pi is 0 again, sine 3 pi by 2 is minus 1, and sine 2 pi is 0 again. So a rough sketch of sine curve is as shown here. Next trigonometric function is cos theta. Cos 0 is 1, so this curve starts from point 0, 1 on y-axis, then cos pi by 2 is 0 again, cos pi is minus 1, cos 3 pi by 2 is 0, and cos 2 pi is 1 again. So the rough sketch of trigonometric function cos theta is as shown in this figure. Next trigonometric function is tan theta. So let us see how to draw a rough sketch of this curve. Tan 0 is 0. So the curve emerges from 0 and moves towards positive infinity because tan pi by 2 is infinity and theta lies in the first quadrant. 0 to pi by 2. Tan pi is 0, and since theta lies in the second quadrant, from pi by 2 to pi, tan theta is negative. Therefore, the curve emerges at pi and moves towards negative infinity because tan pi by 2 is infinity. In the third quadrant, between pi to 3 pi by 2, tan is positive. Therefore, the curve emerges from pi and moves towards positive infinity because tan 3 pi by 2 is infinity. Between 3 pi by 2 to pi, angle theta is in the fourth quadrant, and since tan 2 pi is 0, curve emerges from 2 pi and moves towards negative infinity because tan 3 pi by 2 is infinity. So the rough sketch of tan curve is as shown in this figure. X square upon a square plus y square upon b square equals 1 is equation of this ellipse where length AB is known as major axis, length CD is known as minor axis of this ellipse, distance OA, which is A, is known as semi-major axis, and distance OC, which is B, known as semi-minor axis. So from the known lengths of major axis and minor axis, we can plot points A, B, C and D and draw a smooth curve passing through them known as ellipse. So this curve ABCD is an ellipse. One more point to be noted here is whenever there are even powers of x and y, the curve is symmetric about both x and y axis. So this ellipse is also symmetric about x and y axis. Next curve is hyperbola, whose equation is x square upon a square minus y square upon b square equals 1. Because of even powers of both x and y, hyperbola is symmetric about both x and y axis. Moreover, length AB will be 2a. Next curve is rectangular hyperbola, whose equation is xy equals c or y equals c upon x. This curve is restricted to first quadrant and third quadrant. Next curve is curve of log function y equals log x. The curve cuts the x-axis at 1, 0 because log 1 is 0, and the shape of the curve is as seen in the figure. Next curve is of exponential function y equals e raised to x. It cuts the y-axis at 0, 1 because e raised to 0 is 1, and its rough sketch is as shown in this figure. Viewers, if you like this video, please click the like button. Share this video with your friends and classmates. Subscribe to this channel. Post your constructive comments to make the videos better. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. See you in the next video. Until then, keep watching Number Collage. Thank you.